Okay, so we've been working with rational expressions, simplifying them. Now we are getting to using some operations with these more complicated rational expressions. And so we have that little tune 7th grade came up with. Rational is divide. So we know when somebody says rational, you're thinking fractions. And when you're adding fractions, what must be true?
The same denominator.
Good. Like denominators. Complete this expression. A over C plus B over C, Ellie, equals?
It was B over C.
Over just a C, that's right. Okay? So once you have your like denominators, we know we just add the numerators. Same thing is true over here. Sabrina, finish that one for us.
And that's B over C.
Good. So once you have like denominators, we can combine the numerators and the denominator remains the same. Okay, so let's try this with some fun things. This is not hard. We have the baby step of adding or subtracting with same denominators. But be careful. The fraction bar, you know, is a grouping symbol, right? So it's hard to go wrong with addition for most people, but subtraction can be a problem. Looking at question A here. We have like denominators. So Haley, tell us what we're going to have here.
It would be 2x plus x plus 1 over x plus 2.
Good, over x plus 2. And so how many x's do we have in that numerator?
So it would be 3x.
Good, 3x plus 1. We can put that coefficient 1 there. X plus 2. And can we simplify?
No.
No, we cannot. Cannot. Okay. If we knew what x was, of course we could. Okay, who thinks you can tell us the answer to the second one? Tom.
3x minus 2 over 5x.
Does anybody have a different answer? Madeline? Who has 3x plus 4 over 5x?
I'm so confused.
So, okay, so look at what we have going on. We have 4x plus 1 minus what?
X plus 3.
The entire thing. X plus 3. So when you distribute this, we are subtracting 1x, which everyone will do. That's never a problem because it was in the lead position. But we are subtracting 3. So this is correct. So this is really important today. When you say subtraction with your polynomials, don't forget to put a parenthesis around your numerator. Subtract every term, not just the leading term. Unfortunately, that answer will always be there on a multiple choice test because it is the most common error. So don't make that mistake. Put parentheses around your numerators, okay? And try these and come back and check your work. Okay, so here we have our two answers. Simplified expressions, remembering, of course, to distribute your negative when there is subtraction. So beware of that. Check your work carefully. Okay, before we start adding and subtracting more complicated ones, we have to talk about least common denominators. We have two fractions. Before adding or subtracting, we must have a least common denominator. And now the fractions are polynomials. In this case, they're just little monomials, but they're going to get fancier. So, how does one find the least common denominator? Or does somebody want to tell us what it is in this case? What is the least common denominator? Do you know, Johnny? Do you know?
4x.
Okay, you're thinking of the GCF, like a greatest common factor. But a least common denominator is, what could they both become? What's the smallest thing they both could become? 12x squared, right? Okay. Imagine there was no variable there. what would be the least common denominator for 1/12 and something over 4? It would be 12, right? 12. They both could become 12. 12 times 1 and 4 times 3. Okay? And so what we've learned in the past, and you've been doing this since 5th grade, not with polynomials, but with regular numbers, is that you could take these numbers and you could do your prime factorization, your factor tree, right? So 12 is actually, give me two factors.
4 and 3.
4 and 3, right?
I did that again.
2 times 2, and then I could bring this down times 3, and I could bring the x down. So if we write the factors of 12x in exponential form, how many 2's? 2 squared times 3 times x. There's your factor tree for 12x, right? Now we do the same for 4x squared. And what are the factors of 4?
2x.
And then we have x times x. So if we write this exponentially, we have 2 squared times x squared. So when you're looking for the LCD, you are using, let's see, here's a 2 squared, here's a 2 squared. So what will we use in our LCD? One of them, only one of them, right? We don't need both, so we'll just use one, since they both have 2 squared. How about 3? This one has 3, that one doesn't. Do we use it?
No.
Yes, we do. We use every factor, and if they share one, we use the greatest degree, right? So the greatest exponent. So we're using 3. They both have x's, but this one's x squared, so what will we use? X squared. And you can see we have 4 times 3, which is 12, x squared, which is the LCD, okay? So you use every factor that either has, if one has a higher degree factor, then you use it, if they have the same factors, right? You've been doing this since 5th grade. I know it's a challenge, but now it's, let's put this little note down. I can get this to work. Here it is. The LCD is the product of the denominator's factors. Each factor is used once. Okay, so now look, we're looking for the LCD. And now we're applying this to something that has very different kinds of factors, polynomial, right? So we have to factor these things and see if they have any common factors. The right one is pretty easy. It's just x plus 2 happening twice, right? 2 of them. But over here, what are the factors of this? And tell me, Kate Patasa, what are the factors?
2 and 3, so it would be negative, what? Wait, it would be
8.
negative 3 and positive 2.
Okay, and then this one has x plus 2, whoopsie, happening, twice. It's the square of a binomial, right? So now when we find the LCD, we're going to use every factor, but where they have a common one, we use the higher degree. So, do they both have x plus 2? Which one are we using?
X plus 2 squared.
X plus 2 squared. That takes care of this one over here, that's just a first degree. And then this one has x minus 3, do we use it?
Yes.
Yes. So the common denominator would be that, the least common denominator. Now, if we didn't find the least common denominator, we would have much more complicated expressions. And we would if we just multiply that denominator with that denominator, we would have x plus 2 times x plus 2 times x plus 2 times x minus 3. That would be a common denominator, but it's not the simplest one. And believe me, you want it to be simpler so that you can look for ways to reduce it. Because that's what the goal is to reduce these things, right? This one's a little bit easier, I think. Okay, so when you see these denominators and they do not look like factors, what do? Put them in what? Parentheses. That's all, put them in parentheses. Now you're thinking of them as something you could multiply to something else, right? So this is a factor, this x minus 8. A fraction bar is a grouping symbol. We are just finding the LCD. We're not adding yet. We're going to do that in a second. But what would the least common denominator be in this case? I mean, this one has a factor of x minus 8. That one doesn't. Do we use it?
Yes.
Yes. That one has a factor of x plus 1. Do we use it?
Yes.
We use every factor. And in this case, they were completely different factors. So the reason we're starting with this is we're looking for LCDs, and now we're going to blow fractions up. Okay, so okay, so we have the LCDs for 3 and 4. Okay, so we're now ready to find common denominators and add. So what would the LCD be for these two fractions here? Okay, Beardall. We need an LCD for these two fractions. So what's the smallest denominator they could become? Good, 18x squared. They're both going to become fractions with that denominator, 18x squared. So we come back up here, we say, what do we do to this denominator, 18x, to get to 18x squared? By x. So what must we do to the numerator? Multiply by x, right? We're multiplying by a factor of 1, which is specially chosen to give us this denominator. And so the numerator is now 6x. Okay, what are we multiplying this one by? 3. So multiply the top by 3. And we have 12 over x, 18x squared. And so now that we have like denominators, we can add the numerators. What is 6x plus 12?
6x plus 12.
6x plus 12 over 18x squared. Now what do you notice about these numbers?
Well, 6.
They all have 6, factors of 6. So let's factor out a 6. We have 6 times what in the numerator?
6 times x plus
X
2.
plus 2. And in the denominator, we have 6 times what? 3x squared. So there we go. Our answer is x plus 2 over 3x squared. We don't even need the parentheses, do we? Do you see that we could have simplified the original expression? Right here, we could have simplified earlier on. But when you don't see that earlier, then you'll have to do it later, like we did when we factored out the 6. Okay? Okay, so now we need an LCD. So Jack Borman, what's the LCD here? Again, we do this, okay? These are the two factors. So the LCD will be and y plus 2. Both of them. So what do we have to multiply this first fraction by to get this y plus 2 in the denominator? Y plus 2, right? Over, under, y plus 2. It's an interesting one, isn't it? We're blowing the top and bottom up by y plus 2. And why don't we go ahead and distribute the y to those terms? And what do we get? Plus 2y. Because ultimately we're adding like terms in the numerator, so we want to have just things to add rather than factors. And what will we multiply both the top and bottom by here?
Y plus 1.
Good, y plus 1, y plus 1. And when we distribute, we end up with plus 3. Good. Now we're ready to combine. And what do we have in the numerator? Y squared
Plus 5y.
plus 3. Now, do you think it's possible we could reduce this? I mean, we could factor that numerator. Is it factorable? Are there factors of 3 that add to 5? If there were if this was a 4y here, we could factor this and maybe reduce, right? That would be a final step, but this is not a factorable numerator, okay? 20 minutes. Okay, and so that's it. Be really careful in checking your work as you're doing this assignment. You have 20 minutes in class.